Okay, the second type of molecule, I said there were two major types of molecules. There are more, but these are the two major ones, are called ionic. In ionics, we commonly call them salts. So we think of salt as being something we put on the French fries, but don't forget there's other types of salt, like the salt that we would put down to melt snow. So by definition, an ionic is a metal plus a non-metal. If you ever find a molecule and the first element, so the first one you see, if it's on this side of the periodic table, that will be an ionic substance. The second half of the molecule will always come from this side of the periodic table. So if we look at MgO, once again, look up the Mg. It's a metal. It's to the left of this staircase. This staircase is the big divider in chemistry. Anything to the left is called a metal. So, same first step. Draw Lewis structures. So I've got an Mg and I've got an O. Okay, next thing, square brackets. This tells you that it's ionic. This is the way that we communicate in science. If you ever see a drawing like this, we know that it's a salt. Now, the next thing is transfer electrons from metals to non-metals. So, the metals lose all the electrons and the non-metals gain all the electrons. Now, I'm going to draw the electrons that were transferred from magnesium as X's, just so you can see that they were transferred over. Last step is assign charges. So, if you lose electrons, you've got more protons than electrons, you become positive. If you gain electrons and electrons are negative, you become negative. The metal, which is always written first, will become positive. The non-metal will become negative. Once again, electrons are negative, so if you're gaining electrons, you're becoming negative. I know that's counterintuitive. You're going to have to think your way through that one. Remember, the one that we have the least of goes in the middle. Square brackets. All of the electrons get transferred to the S, which is our non-metal. We know it's the non-metal because it comes second. Non-metal always comes second. So we've transferred those electrons over. It's gained 2 electrons. These have each lost 1 electron. If you lose electrons, you become positive. Last one, Ca, whatever you have the least of goes in the middle. Cl2, 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7. I wonder if you know which way the electrons are being transferred here. The electrons always go from the metals to the non-metals until the outer shell is full with the non-metals. So as soon as it has 8, it's got as many as it can take. Remember that rule. As soon as it's got 8, it's got as many as it can take. Now, the last thing that I want to show you, and you won't find this on a worksheet, but when you have an ionic substance and you see MgO, it doesn't mean one Mg and one O. So if it's CO2, which is covalent, it literally does mean one C and 2 O's. But what MgO means in ionic is you've got a repeating pattern. That's a 1-to-1 ratio. And basically, you'll have to excuse my drawing, but I said we're dealing with salts. So what this means is we've got a salt crystal which has a ratio of 1 mg to every O in that crystal. Where if it was a covalent substance, something starting with a non-metal, if it said CO2, it would literally just be CO2. Okay, folks, there will be a worksheet or some worksheets coming your way for the afternoon, and those will be sent to you, and good luck with this.